Okay, let's look at how to solve for back titration equations today. Now, back titration is carried out when you cannot carry out normal direct titration. For example, when your solid cannot dissolve in water. So if you cannot dissolve in water, you cannot titrate it directly with your reagent. So in other words, you need to conduct a back titration. So how do we do that? We will dissolve it in a known excess of HCl, and then later we titrate against this excess HCl to find out how much HCl reacted with your calcium carbonate. So for example, let's look at this question here. Okay, you have 0.7 gram of impure calcium carbonate. I cannot take 0.7 divided by MR because this is impure. Okay, so there is 0.7 gram of calcium carbonate added to your excess HCl. So this excess HCl, this HCl will be in excess. Okay, so your calcium carbonate will react with your excess HCl. There will be HCl left over, which you will then transfer to a volumetric flask, and you will dilute it up to 250 cm3 over here. Then you pipette out 25 cm3 and you titrate that against your sodium hydroxide. So your sodium hydroxide here will tell you how much is your excess HCl. So you're using this amount of NaOH. Okay, it will tell you how much excess HCl is in your 25 cm3. So for back titration questions, we will start from the back over here. Okay, you cannot start from here because this is impure. Okay, so instead we will start from the back. So first, you will find your number of moles of your number of moles of sodium hydroxide. Okay, over here, which is 24.35 over 1000 times 0.05, the concentration times volume. You'll get 1.22 times 10 power minus 3 moles. Okay, the NaOH and HCl will react 1:1 ratio. So therefore, this will also tell you the number of moles of HCl in 25 cm3 of your solution. Okay, and next you need to work backwards. You need to scale it back up to find your number of moles of HCl in 250 cm3, which is 1.22 times 10 power minus 3 times 10. So this is 1.22 times 10 power minus 2 moles. So this moles of HCl in 250 cm3 is your excess HCl that is left over after your reaction with calcium carbonate. Okay, so now I'm going to find the moles of HCl that reacted with calcium carbonate. So you just take your initial will be your 25 times over 1000 times 1 minus your leftover. You'll get 0.0128 moles. Okay, now next let's look at the mole ratio. How does HCl react with calcium carbonate? They react in a 1:2 ratio. So therefore, the moles of calcium carbonate that reacted with the HCl will be 0.0128 divided by 2, which should be 0.0064 moles. So now you know your moles of calcium carbonate in 0.7 gram. Let's find the mass of calcium carbonate. This will be 0.0064 multiplied by the MR, which is 40.1 plus 12 plus 3 times 16, 100.1. 0.641 gram. Next, they ask you to find the percentage purity. So all you need to do is take this mass divided by the impure mass, which is 0.7 gram, and multiply by 100. You get 91.5%. So this will be your percentage purity. Okay, so there'll be a slight difference with this answer depending on whether you're using the calculator value or whether you are using the rounded off value. Okay. So you could get a range between 91.5, 91.6, or 91.7%. It's just a small difference depending on how you rounded off the values. So this is how you conduct and do back titration questions. This 1 minute of chemistry. See you the next time.